all these videos that I'm making of the test so that you can, at home at least, study. Like, please don't just watch the video casually. It won't help you. Like, study it. If I say make a flashcard, make a flashcard. You need to take some of these home, take some home. They are for you, so just you take what you need. But anyway, that's how you're going to prepare for the retake, is by coming here, but also using the videos to your advantage when necessary. So what I'll make sure I do in the second retake prep, I will not do any of the same problems we did in this retake prep. Like, I'll make them talk about other questions, and that way we get more videos. Tomorrow we'll see what happens, depending on who's here, but and kind of how many questions we get answered. So 7, yeah, Parker?
Yeah.
7? Yeah, guessing not a really good strategy.
Well, I forgot what like E is.
It's all right.
I forgot like
It's totally fine.
except I guessed.
I always tease about guessing because we've all had those classes where, like, okay, I'm kind of bragging, but I'm pretty good at multiple choice tests. I am. And it's because most of the time multiple choice tests, they just ask your brain to like remember something that's familiar. They don't ask you to actually solve anything. Calculus isn't like that, you know. So anyway, I'll stop talking now. Okay, here we go. Okay, so for those who just joined us on the video, we've been talking about the limit flashcard. Here it shows up again. Here's my limit flashcard. And I've got to fix this. It's going to drive me crazy. How do you make this thing? Oh, well. So you've got to have the limit flashcard. This problem, unfortunately, x approaching infinity. But there's nothing to add, so we can't really do that. We can't factor and divide because there's nothing to divide. We're stuck with remembering. I don't know how to make a flashcard on this one. I'll explain the idea. If you can think of a flashcard, please make it. As x approaches infinity, x to the 7th will approach infinity also. As x approaches infinity, e to the 2x also approaches infinity, but it does it so much faster. So you end up with a pattern that looks something like this. Okay, here's what's hard about these types of problems. We are dealing with numbers that are difficult for human beings to think about because they are so large. So we're going to think about numbers that are small because it's easier for us to think about them. You have to pretend they're much bigger. Like when I write 1, you should think of like 1 with 100 zeros. You with me? Like I write 1, but you think of like 1 with 100 zeros. As x approaches infinity, that's what's going to happen to the top. It's going to get big. Okay? The bottom will also get big. So 1 with 100 zeros. But the bottom grows faster than the top by a lot. So as x gets larger, maybe the top changes to 2 with 100 zeros. Guess what happens to the bottom? It becomes this. It becomes 100 with 100 with 100 more zeros, like 1 with 200 zeros. It's enormously larger than the top. So raise your hand and tell me, where is that headed? Is that getting close to infinity, close to 0, close to a number? Hands, come on. If that's the pattern, what's going to happen? What is going to happen? Let's go, try to pick somebody new I can talk to. Patty. Yeah, 0. Please, Sydney.
So he's the one that gets really, really big fast, and then ln or natural or whatever, it gets really slow.
Yes, the 3 they test you on are power functions. So Sydney's question was, and I'm kind of paraphrasing, but Sydney's talking about, okay, what are they going to test me on? What they test you on is power functions. Here's a power function. They grow rapidly. But exponential functions, here's an exponential, grow much faster. They also like to throw in log functions that grow the slowest. And I think I actually had a memory on this reference sheet to remind you of that. Maybe I didn't. Nope, my bad. Should have had something on there. Did that answer your question, Sydney?
Yeah.
Okay, 3 points. What do you else? Oh, please.
I'm still just kind of confused on how you get 0.
No worries. Let's think of a pattern that's a little easier to follow. Again, don't think of it as the real numbers, just the idea. So the idea is that we have x, and then we have this thing, x to the 7th divided by e to the 2x. And I can't do the real numbers, they're too difficult. So I can just show you the general pattern. So as x grows, it gets bigger and bigger. Both of these grow. So maybe they actually start out kind of the same size. The top grows, the bottom grows a lot faster. The top continues to grow, the bottom continues to grow much faster. Can you see where the fractions are headed? Does that answer your question? Perfect. 2 points for Parker. Anybody else here? Please, Marianne.
So did you say, so like if x is in the exponent, it grows the fastest, right? And then if it's just x, it's like in between, and then log of x is the slowest?
That's the general trend. Let me say it again for the video. Now, I have to be honest, Ariana, they can get pretty tricky with these kind of problems. They haven't typically, but be a little careful. But the general idea is that if I have a base that's a number, like e is a number, 2.7, and I have an exponent that's going to grow. Whatever the exponent is, if it's getting bigger and bigger and bigger, that's going to grow the fastest. If I have a base that's going to grow, and the exponent's a constant, that also grows fast, but just not as fast. And the last one is if I have the natural log of something that grows, that also grows. Where you have to be a little careful is that they start putting negatives like here, or negatives here, or negatives here. I have to think about it a little differently. So, 3 points. Anybody else? Okay, we have time for one more before we have to switch sessions. So stop that.